YouTube. Welcome back. Today we will talk about graph databases. So we will talk about what are the graph databases, why do we need them, and when to use them. So let's go about the why first. Um, Graph databases are a type of NoSQL database, especially designed for working with highly interconnected and complex data. They are designed to store and manage data in a way that represents relationships and connections between entities as a graph. In a graph database, data is stored as nodes representing entities and edges representing relationships, making it particularly well suited for scenarios where understanding and querying relationships are essential. So, and this is example of how we can see it. Like we have each one node, and we have the connections between them, and it's a quite complicated one. So why do we need the graph database? Basically to achieve this type of problem, because we have right now, as you can see, we have multiple users. They have a lot of connections between them. It's quite complex if to use it in tables. So we use graph to store the nodes, and we have edges representing the relationship. So this is an edge, and they have a relationship between each other. Like this one follow this one. This one is following this one. Did this user make a like on a comment of this user? It's a quite complicated. If you thought about Facebook as an example, it's a great it's a way more better solution to use a graph database instead of a SQL or no SQL type database. So let's talk about why do we need it. Let's talk about the why first, and let's make this quite smaller. And I'd like to make the y with the red and make it with numbers. And so the first thing that I will say about why we needed the efficient relationship modeling. So graph databases excel at modeling complex relationships between data entities, such as social networks, recommendation engines, fraud detection, and knowledge graphs. Traditional relational databases struggle with complex joins and queries involving many tables, while graph database handle this naturally like butter. Also, you talk about the flexible schema. So, unlike traditional relational databases, graph databases typically have a schema-less or flexible schema model, allowing you to adapt to changing data structure and relationships without significant schema modifications. Also, why we need it for performance. So, for querying that involves traversing relationships or finding the shortest path between nodes, graph databases graph databases offer excellent performance. So they are optimized for these types of operation, which are often slow and inefficient in other databases. It's a great also in real-time insights. So graph databases are valuable for real-time data analysis and discovery. They allow you to gain insights into relationships and patterns with your data in real time, which is essential in applications like fraud detection, recommendation systems, and network analysis. Also, it's a great when it comes to the natural language processing. So graph databases are often used in natural language processing tasks, such as semantic analytics, chatbots, and questions answering systems, where understanding the relationships between words and concepts is critical. So we also have the last two, which is it's a great in hierarchical data. So when dealing with hierarchical data or tree-like data structures, such as organization charts, file systems, and product category hierarchies, graph databases can represent these structures more intuitive than relational databases. Lastly, we have geospatial data. So graph databases can be efficient to handle geospatial data and queries, making them suitable for applications involving location-based services and mapping, geospatial analysis, etc. So let's ask the second question, which is, when do we need to use a graph database? So let's make this one with green, with numbers. So the first one, I would say, if we have a highly connected data. So if your data has many relationships and connections that are central to your application's functionality, consider using a graph database. It will be great to use this one. We will say when you have a complex queries. So when you need to perform complex queries that involve traversing relationships or finding patterns within the data, a graph database can simplify and speed up these operations. Also, it's a great in scalability and performance. So graph databases are designed to scale horizontally to handle large and growing datasets. If you anticipate the need for scaling and high performance queries, graph databases are a good choice. Also, it's a great when it comes to real-time recommendations. So for applications that require real-time recommendations, such as e-commerce product recommendations or connected recommendations in media streams platform, graph databases can provide relevant and up-to-date suggestions. It's a great in network analysis. So in network analysis and social network applications where understanding connections influence is crucial, graph databases are the go-to choice. I would say number 6 is knowledge graphs. So for building knowledge graphs that represent structured information about entities and the relationships, graph databases offer an efficient way to store and query data. And lastly, we have a semantic data. So if your data includes semantic relationships between concepts or entities, graph databases can help capture and query this semantic information effectively. So it's important to note that while graph databases are powerful for certain use cases, they may not be the best choice for all scenarios. For more straightforward tabular data within minimal relationships, traditional database may be more suitable. And that's the choice of the database technology should align with your specific data modeling and query requirements. So that's it for today's video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you never miss a video, and see you in future problem.